Hi, Chem team. So you guys know that if we were to zoom in on a droplet of water, to the point where we could see the water molecules, we know that the water molecules would be made of 2 hydrogen atoms and 1 oxygen atom. And furthermore, we know that because hydrogen has an electronegativity of 2.1 and oxygen has a higher electronegativity of 3.5, that oxygen would be able to attract the electrons it shares with the hydrogen atoms toward itself. In the process, oxygen becoming slightly negative and hydrogen becoming slightly positive. Now, what's interesting about this process is that these slightly positive and negative ends of the water molecule are able to attract other water molecules and form connections with those molecules. Now, we call these connections that form between water molecules hydrogen bonds. And we say that those are intermolecular attractions because they're attractions that occur between separate molecules. Intermolecular literally meaning between molecules. And what you'll notice about these hydrogen bonds is that they always form between the positive and the negative sides of 2 separate molecules because the opposite charges are attracting. Now, these hydrogen bonds give water some interesting properties. For instance, water has surface tension. That is, if we were to zoom in to the surface of water, we could see that the molecules in water are able to attract together through hydrogen bonding. And as a result, they're able to support weight at the surface. We call this ability of water to stick to itself cohesion. Now, cohesion also will affect the boiling point of water. Because normally in nonpolar substances, when you add heat to a nonpolar substance, the molecules within that liquid substance will speed up until they get enough energy to break into the gas phase. And we've shown that here. That's when boiling occurs. Now, with water molecules, or a polar substance, if you were to look at what is occurring near the surface of a polar substance that's being heated, what you'd see is that the hydrogen bonds are actually attracting the water molecules together, which is preventing these water molecules from breaking out into gas phase. As a result, water needs a very high temperature in order to boil. Now, of course, water can stick to other things too in a process called adhesion. We can see an example of adhesion here as this water molecule sticks to the bottom of the leaf. And one of the most important examples of adhesion in biology is how plants absorb water. If we were to zoom in on the stem of this tree or the trunk of this tree, what we could see is that water molecules are able to stick to the sides of the tree's stem tissue. And as a result, they're able to kind of climb up or stick their way up through the tree's stem, up into the leaves of the tree where it's used. Okay, we call this process of adhesion up through a tube capillary action. Capillary just meaning a very thin tube. And that's it. At this point, you guys have a couple of practice questions. We'll see you in class tomorrow.